Welcome back to 6-Minute Statistics. In this video, I'm going to do the unthinkable. Solve probability problems without using formulas. Impossible, right? Not when the data are already collected in a probability table. Why don't you give me 6 minutes and I'll show you how. Let's go!
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hello again, Mark here from 6-Minute Statistics, and I want to start this video by thanking you for finding my YouTube channel. I love that students are interested in learning statistics, and I want to be a place where you can gain information. What I'd like you to do is to help me spread my information by liking this video and subscribing to my channel. Also, if you know somebody that's struggling with statistics, why don't you send them a link or share my information so that they can benefit as well. Thank you. Before I leave the formulas behind, let's take a look at the common probability rules everyone starts with. Scary, right? I'm going to put a link at the end of this video to another video where I've gone through and shown you how to use these rules. In this video, however, I want to show you that using these rules is not always necessary, and sometimes it even gets in the way. To do this, I'm going to need an example. For an example, I tried to come up with something even scarier than these probability formulas. You know what I came up with? Clowns. Yeah, clowns. Scary, creepy, weird clowns. That's what I want to use. I read a recent article in the International Journal of Mental Health that suggested 27.6% of adults reported a fear of clowns, with 5.1% of them rating their fear as being extreme. It also suggested that females fear clowns at a higher rate than males, and younger adults at a higher rate than older adults. I decided to take a sample of 500 adults and ask them to rate their fear of clowns as either no fear, a small level of fear, a moderate level of fear, or extreme fear. I also broke the results down by age group, with younger adults, middle-aged adults, and older adults. You see the data in the table on the screen next to me now. Now let's take a look at some common probability questions you may be asked and see if we can answer them without using the dreaded probability formulas. Let's start with an easy one. What proportion of adults have no fear of clowns? We look at the table and look for the total in the none column and see 280 adults reported as having no fear of clowns. To express this as a probability, we divide the 280 by the 500 total adults sampled and find that 0.56 or 56% of the adults sampled have no fear of clowns. Simple, right? All right, let's do an AND question. We looked at AND questions when I went through the multiplicative rule. What proportion of the sample were middle-aged and have a small fear of clowns? Some may try to force the multiplicative rule on you to solve this, but I think it's easier with just using common sense. Look at the table again and try to find which adults have both outcomes, both middle-aged and small fear. 50. 50 out of the 500, right? 50 out of the 500 or 10%. That's it. We could use the multiplicative rule, but it'd make it much more difficult. You don't want that. How about young and extreme fear? There's 10 adults that have both those categories, right? 10 out of 500, 2%. That's the AND question. Now let's try an OR question. The additive rule is what we use for OR questions. What proportion were older adults or, not and, but or had an extreme fear of clowns? It's a classic OR problem. It is so tempting to use the additive rule. Let's try to solve it without the formula. We see 150 older adults were sampled in the table, and we see 28 said they have extreme fear. Can we just add these two numbers together? Can we take the 150 and the 28? We can't, not in this case. Why not? Because 3 of those people sampled had both categories. They were both older adults and had extreme fear. And so we're going to take the 150, we're going to add the 28, but then we're going to subtract the 3 so it doesn't get counted twice. So we're going to get 150 plus 28 minus 3 or 175 out of 500, which is 35%. You may see the additive rule at work even though we're not specifically going to it. The probability of one event plus the probability of the other minus the probability of both. We're just using common sense to solve the probability. Let's try another OR problem. How about young or moderate fear? Same idea, just different numbers. In this case, add the 150 younger adults to the 67 moderate fear and then subtract the 20 that fell in both. You come up with 197. 197 out of 500, or 39.4%. Again, easier without the probability formula. So that's the and and the or. How about conditional probability? Try solving this one. Given that the adult has extreme fear, what is the probability they were a young adult? Now, we could look back at the formulas I presented earlier and find that nifty conditional probability formula, or again, we could use common sense. In this problem, we're only interested in adults with extreme fear. That's the information we've been given. So let's restrict our look to just those 28 adults who said they had extreme fear. We're not going to look at all 500 in this case. We're going to look at just those 28. Now, of those 28, how many were young? 10 of the 28, or 35.7%, were young adults. Go ahead, check me using the conditional probability formula. While you're doing that, I'm going to answer another conditional probability using common sense. Given that the adult is an older adult, that's our given part, what's the probability they have no fear? All right, so let's take a look at the 150 older adults, and of those we see 90 had no fear, so 90 out of 150, 60%. How's that formula working for you? I'm telling you, when data are given in a table like this, leave the formulas behind. Just use common sense, and you in the back, say it with me. Keep it simple, student. Kind of liberating, isn't it? No formulas, correct answers, win-win. Know what you're thinking. You're wanting to go and practice on your own to see that you really understand how this works. That is music to my ears. Before you do, don't forget to like and subscribe to my channel. You guys are the best. Now, it's time to get to work. See you next time.